It's totally cool. All right, so R1 warm-up says it starts with find the distance and then the midpoint between the given points. Remember our distance formula, which is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So if I plug those points in, I get the square root of 1 minus a negative 4, which is plus 4 squared, plus negative 4 minus 7 squared. I get the square root of 5 squared, plus negative 11 squared, 25 plus 1, 21, and I get 146. Okay, it's a pretty big and it's an even number, so you definitely want to check to make sure that doesn't break down. This would be 2 and 73. Okay, which is prime, that's going to stop, which means I can leave this as the answer. You just want to make sure you check to see if it can be simplified. The midpoint, which our formula is x1 plus x2 over 2, and then y1 plus y2 over 2. So I'm going to add the 2 points together, divide by 2. So negative 4 plus 7 over 2, and then 7, wait, just kidding, negative 4 plus 1 over 2, and 7 plus negative 4 over 2. I get negative 3 halves and positive 3 halves. And there's your midpoint. Everybody good so far? Yes? Okay, just don't make silly mistakes there. That's what's going to happen. Okay, if you hopefully by now we know those formulas. It's just going to be silly errors. All right, the second one says show that the points form the vertices of an isosceles triangle. Remember that just graphing it is not enough information. So you can graph it so that you can get an idea of what it would look like. 1, 1, 2, 3, negative 3, 1, 2, 3, 2, and negative 2, 1, 2, 3, 4. So what's the perk to graphing it ahead of time? You can kind of look at it and say which of those two side lengths might appear to be the same. You with me? And then I eliminate the extra work. You might not catch it. It might be so close that you might not catch it. But if you can catch it, or if it's a horrible drawing like mine, it's not perfectly accurate, but you get the point. Okay? So this was my 1, negative 3. This is my 3, 2. And this is my negative 2, 4. And it looks like maybe these two are closer in length than the other two. So I'm going to try those first. So I'm going to first do these 2 points. I get the distance equals 3 minus a negative 2 plus 2 minus 4. 5 squared, negative 2 squared, 25 plus 4, square root 29. Then I'm going to try these two. And I get the same length. So because those are equal, this becomes an isosceles triangle, okay? So by plotting your points, you might be able to eliminate some work for you. If you don't, then you do all 3 side lengths. You just got to show that 2 are the same. If the question said, let's say like my answer was for the length of a side was square root 20. If I'm just showing that they're isosceles, you don't have to simplify that square root. But on your quiz, it's going to ask you to find the lengths of all 3 sides and then classify it. When you give me the lengths of your sides, that square root better be simplified. Okay, so you want to make sure that if it can be simplified, it is. Obviously, 29 is prime. You can't break that down, but you want to make sure you're checking. Questions on the warm-up? Okay, so I am going to go through the solutions to the R1 homework. Remember that R1 and R2 are not in your book. That's why we're going to go through them all. Once we get to WebAssign, which will start tomorrow, you will be responsible for checking your answers. After the due date, so after 8 a.m. on the due date of the assignment, the answers will show up. And you can check your own answers, okay? I want you to check them, see if you have questions, and then come to class with questions. So you're doing that ahead of time. I'm not going to individually go through and go over every answer because WebAssign produces different problems for different kids, and I can't possibly go through all the versions. Does that make sense? So after 8 a.m. on the due date, if you go back into WebAssign, you can actually click on Show Key, and it will show you which ones you got right, which ones you got wrong, and if it's wrong, what the correct answer is. Okay, so it's kind of on you to be checking your work. All right, so this is R. I know it says 1, 1 at the top, but this is R1. Okay, 6. Those are your points. Obviously, you needed to point or plot those points, label them in some way so you know what was what. 8 should have been negative 12, 0. 10 is quadrant 3. 12 is quadrant 3 or quadrant 4. 14 is quadrant 1 or quadrant 3. Your scatter plot should have looked something like that. It doesn't have to be perfect, but something like that. They went by tens on the y-axis and by single tick marks on the x-axis. But the shape should have done something where it came up and came back down. Okay, this is a bell curve shape. You could infer that it's hotter in the middle months and cooler in the winter months. You can infer that I would never move to wherever this is because I don't want to live where it's negative 39 degrees ever. But that's that bell-shaped curve. Questions on any of those? Okay, 18 was the square root of 289, which is 17 units. 20, square root of 29. 22, square root of 296.2. Without a calculator, you would keep it like that. With a calculator, you would approximate that to be 17.21 units. You won't have a calculator on this first quiz. 24, you're showing that the distance is the same. A squared plus b squared would equal c squared. 26, you're showing that two side lengths were equal, which is the square root of 20 and the square root of 20. It also is a right triangle because square root 20 plus square root 20 squared equals square root 40 squared. 28, two sides were the same. This is isosceles. 30 was plot the points, find the distance, which is 7, find the midpoint, which is 9/2 and 4. 32, plot the points, find the distance, which is 13, find the midpoint, which is 7/2 and 6. Questions on those? 34, plot the points, find the distance, which is 8 root 2, that needs to get simplified, and the midpoint, which is 6, 6. 36, distance is square root of 82 over 3. Midpoint's -1 and 7, 6. 38 was, if you left it without a calculator, to 2 root 505, approximately 45 yards if you had a calculator. Questions on those? Okay, and then your scatter plot was based on your information. You should have also included that in your homework. You had to find the midpoint between those points, which was the year 2009. The earnings per share were about $2.36. 42, 33, 10, 3, -3, 50. That's a shift up, no, to the right, sorry, 6 units and down 3 units. And then 44 was a shift down 10 units and left 6, so it's -5, 2, -7, 0, and -3, 0. All right, R2 is called graphs of equations. Still in the review mode, okay? So this is still stuff that should be familiar for you. This is nothing new, but there is like symmetry and stuff in here that is always a good refresher. All right, we start easy again. Points on a graph. So if a point's on the graph, then when you plug it into the equation, the result's a balanced equation. The left side of the equation is going to equal the right side of the equation. So if the question is, does this point lie on the graph, no matter what kind of equation or what kind of point you're given, you can simply plug it in and see if left side equals right side. If it does, it's a yes. If it doesn't, it's a no. All right, example 1 says determine whether the given points are on the graph of the equation. So this is a two-part question. It's giving you the equation and it's giving you 2 points to try. I'm going to try the first one. So if I take and plug in the 0 as my x and the 2 as my y. Everywhere there's an x, I'm getting a 0. Everywhere there's a y, I'm getting a -2. So I get 0 plus 0 plus -2 squared, which is 4, equals 4. And 4 equals 4. Is that a true statement? Yes. So this point is a yes. Then I'm going to repeat the process with the other one. 1, 2. And 1, this is -1 plus 4, and I get 3 equals 4. Is that a true statement? No. So this point is a no. Just because one is yes doesn't mean the other is no. You can have multiple points that plug in that would be yes. You could have multiple points that plug in that would be no. Remember, you need to show work for these. Questions on that one? Easy stuff. So standardized tests will give you this big, long, ridiculous equation and then ask you, like, if this point lies on that graph. You don't have to try to figure out how to graph that thing. Just plug the point in and see if it works. If the left side equals the right, it's yes. And if it's not, it's no. All right, graphing using a table. So we're going way back. We're going to pretend like we don't know how to graph or what things are. Eventually, when we get into like parent functions, you'll know how to do transformations and that kind of stuff. But we're going to pretend like we have no idea what a graph looks like. And then we go back to the basics, which is creating a t-chart. So you're going to create it either vertically or horizontal. I don't care which way. You're going to plug in some values. You're going to plot some points. So A and B here actually give you the points to plug in. You just got to plug them in. So if I take and plug in x as -1, I get 3 plus 1, which is 4. If I take and plug in 0, I get 1. If I take and plug in 1, I get -2. Take and plug in 2. I get -5. So then in the box below, you're setting up your coordinate point. -1, 4, 0, 1, 1, -2, 2, -5. And then you're going to go to your coordinate grid and plot those points. -1, 4, 0, 1, 1, -2, 2, -5. Sure, just I know. Under the flag. All right, you do B. So work through the same steps. Plug in each of those points that get your X and Y, and then plot your points. All right, so when you plugged in -1, you should have got -1, 0, 0, 1, 3, 2, 8. And then if I plot those points, I get this kind of curvy shape. Now, you guys are so smart, right? So you knew that by looking at B from the beginning, this should have taken on what kind of shape? What happens if my equation has a squared in it? It's a parabola, right? But we only got part of the parabola, okay, which is totally fine. If I tell you to plug in these specific points, you want to plug in those specific points and get that portion of it, okay? The parabolas, you guys might know that at some point that's coming up on the left, but we don't know yet how far down it's going in order to curve it back up. So even though you think this should have been a parabola, it can just have that portion of your graph, okay? Like I said, when we get into chapter 1, we're going to start doing transformations. You would have known from the beginning that's a parabola, and then you would have been able to plot points accordingly. But for right now, because you're going to get mixed a whole bunch of different kinds of stuff, not necessarily all parabolas, just plot the points that are given to you and don't stress too much about the shape it takes. All right, intercepts. So it doesn't matter what kind of graph it is, you can find the intercepts the same way. The x-intercepts can be found by plugging 0 in for y and then finding the corresponding x. And this is going to be where that graph crosses the x-axis. The y-intercepts is the reverse. You plug 0 in for x, find the corresponding y, and this is where your graph should cross the y-axis. You can have none, one, more than one. Okay, there's no rules here with these. So sometimes it's none for, it could be like a circle that's in the first quadrant and it never touches any axis. Okay, or it could be a circle that's in the dead center of the origin and it crosses through the y-axis twice and the x-axis twice. So there's no set number that these have to be. When you provide answers for these, whether it be homework or quiz, you're going to write them in coordinate point form. So I don't want you to write x int 3. I want you to write 3, 0, okay? So you want it to be in coordinate point form. If it's a y-intercept, you're not giving me y int 2, you're going to do 0, 2. And if there's more than one, you just list more than one. All right, so in this one, there's 3 different ways that you can find these intercepts, right? A gives you the graph as it is. So I don't have an equation. I have a graph. If I want to find the x-axis, I'm looking where? Where this graph crosses the x-axis, right? Here and here. So the x-intercepts would be 1, 0, and 2, 0. And then the y-intercept is even labeled for me. It's where it crosses the y-axis, which is 0, 2. So that's one way. If you have your graph, then you just find your points. For B, I've got an equation. You don't want to graph this and then have to try and find the points from the equation. You want to work through algebraically, which means take and plug in your numbers. So if I'm trying to find let's start with the y-intercept because that's the easiest one. Y-intercept, I plug 0 in for x. So y equals 2 times 0 to the third minus 4 times 0 squared. Y equals 2 times 0 minus 4 times 0, or 0 minus 0, which is 0. So my y-intercept is 0, 0. Which means what about my x-intercept? At least one of them is going to be 0, 0, but there could be more than one, right? So we're going to look for them. So my x-intercept, I'm going to make 0 equal 2x to the third minus 4x squared. How do I solve that? Pull out an x squared. I can even pull out a 2x squared, right? So I can do 2x squared, and I'd get x minus 2. And then if either of those terms or factors are 0, the whole thing's going to be 0. So I would split and solve it at this point. 0 equals 2x squared, and 0 equals x minus 2. Divide both sides by 2 here, and I get x squared equals 0. Square root both sides, applying my even root property, which says plus or minus, and I get x equals plus and minus 0. Is there such a thing as plus and minus 0? No, so it is just 0. But if that was a 4, and I go to square root the 4, you better make sure you include positive and negative 2. All right, so that's one intercept, which makes sense. That's what we found from the first one. And then this other one is just x equals 2. So I have 2. 2 x-intercepts, 1 y-intercept. God bless you. Questions on that one? Okay, for the next one, we're going to jump out and we're going to go to our graphing calculator app so you can kind of see how this works. So we just graphed it based on our graphing calculator. If you have a handheld graphing calculator, again, we'll start to use that a little bit more in the future. But you can also graph it there, and then you can go to intercepts, and you can see your x-intercepts and your y-intercepts from there. If your homework asks you to verify something using a graphing utility, because it will just say utility, you can choose if you use your handheld or if you use the app, but you need to take a picture of whatever it is to bring it into your homework. If it says to graph something and answer questions based on it, and you don't do that, and then your question's wrong, you'll have no idea why it was wrong because you don't know what it looked like when you graphed it. Whether it was user error in you typing it in or if it's you reading the graph wrong. So I expect if the homework says use a graphing utility for blank, whatever it is, that you graph whatever it is, whether it's a handheld and you literally take a picture of your screen and you pull it in, or if it's the graphing calculator app, you screenshot it, you pull it into the homework. Okay, does that make sense? Yeah.
What did we type in? Because I got.
Okay, symmetry. So symmetry, I would say, is probably like the thing that most people get hung up with in this stuff. Okay, there's 3 ways for a graph to be symmetric: to the x-axis, to the y-axis, or to the origin. If it's symmetric to the x-axis, then it means you can fold it from top to bottom like a hamburger, and your graph will overlap. If it asks you to find out if it's symmetric algebraically, then you're doing what it says there. You're taking the y, replacing it with a negative y, simplifying your equation. If it goes back to the original equation or every sign in the entire equation is opposite, then it's symmetric to what you just test for. For the y-axis, your test is to change the x to a negative x and do the same. And then origin is both the x and the y. So the rule is if your equation goes unchanged or each term has the opposite sign than it had before, then it's symmetric to whatever you're testing for. Be careful with the each term because it means on both sides of the equal sign. All right, so test for symmetry, okay? If it says test algebraically or test the equation for symmetry and you don't have a graph, then it means algebraically. If obviously it has a graph, you can just look at it and see if it's symmetric. Can I fold it this way? Can I fold it that way? But if you're going based on an equation, then you're doing this. So if I look at the first one, okay, if I want to test to see if it's symmetric to the x-axis, I got to change every y to a negative y. So x to the fourth, negative y to the fourth, x to the second, negative y to the second, plus 1 equals 0. Now what happens when you raise a negative to an even power? You go back positive, right? So this becomes x to the fourth, y to the fourth, x to the second, y to the second, plus 1 equals 0. Does that go back to the original equation? Does this match that? Yes. So it is symmetric to the x-axis. Now I'm going to do the same thing for the y-axis. Plug in a negative x. Same thing's happening. A negative is being raised to an even power, so it's going to go back positive. And my equation equals my original, so it's also symmetric to the y-axis. And the last test is both. And they're going to go back because they're both being raised to the even power. So this is yes to all three. It can be yes to all three. It can be no to all three. It can be yes to x-axis but not to the other two. It can be yes to just origin and not to the other two. What you want to do is think about ways in which it does go back to the original. So besides being raised to an even power, what else makes something go from negative to positive? Say again? If you're multiplying two the same, so if they're negative x and negative y, they're going to go back to positive. What else? What operation makes something go from negative to positive?
Squaring.
Squaring, right? So raised to an even power. What else? Absolute power. Absolute value, yes? So if you saw an x in absolute value, you know if I plug a negative x, it's going back, right? So sometimes you don't have to go through every single step if you understand. If you know what you're looking for, you don't have to go through every single step. But if you are unsure, you plug them in, you check them, okay? So based on that, yep. Okay. Based on that, look at B. If I plug in a negative x, is it going to go back to positive x? No. So it's not going to be symmetric to y. If I plug in a negative y, is it going to go back to positive y? No. If I plug in a negative x and a negative y, what happens? This changes. This changes. But does the 1 change? No. So this is also no. If that was a 1x, let's just say, now it would be symmetric to the origin because every sign would have been flipped. Or if it was x to the 5th, it would have been to the origin because every single sign is flipped. Did that answer your question, Mary Angel, or you?
No. But
Okay.
So if you have the x and y axis, like the A example, you have to find the origin since both of them are.
If it's both and then the origin is implied, you're good. Yeah. But it can be no and then yes, so just be careful.
And you also said like you can have the origin
Yeah.
symmetrical but not the other two.
Correct. Like an xy.
Oh.
Right? So like xy equals 1. Individually, I can't change just the negative x. I can't change just the negative y, but a negative x times a negative y is going to work. Does that make sense?
Mm-hmm.
Yeah, okay. Mm-hmm. Okay, last thing in this section is circles. So this is a big section, but a lot of review. Okay, last thing in this section is circles. The standard form for a circle is x minus h squared plus y minus k squared equals r squared, where the hk is your center, the r is your radius. So in standard form, an equation would look something like this, where the x stays the x, the y stays the y, but the h, the k, and the r are replaced. So this says find the equation, and we start off easy. I give you the center, I give you the radius. So if this is my h and this is my k, my equation is x minus h squared plus y minus k squared equals r squared. So I would get x minus a negative 2 squared plus y minus 1 squared equals 3 squared. So x plus 2 squared plus y minus 1 squared equals 9. Notice that the signs in your equation are always going to be opposite the signs on your center because your initial equation is negative, so it will always change it, okay? Now B says center and solution point. So I have the center again, right? But what don't I have? The radius. How could I find it? One option, plug those in as your h, your k, your x, your y. So I get 3 minus a negative 1 squared plus 4 minus 4 squared equals the radius squared, 4 squared. 16 equals r squared, so r is 4. And then I take and plug back in just the h, the k, and 4 squared, which was 16. Is there another way to find the radius? What does it mean to be a solution point on a circle? What's a solution point on any graph? Where is it located? On the circle. So what segment represents the distance from the center to a point on the circle? The radius, right? So you could also find the distance between the center and the solution. My opinion, that way we just did it is easier. Okay, so endpoints of a diameter, you're missing both the radius and the center, right? So if I have the endpoints of the diameter, how do I find the center? It's the midpoint. So I'm going to do the midpoint between those two. So 0 plus 3 over 2, 0 plus 4 over 2, and I get 3 halves and 4 over 2. So 3 halves and 2. There's my center. So far I'm x minus 3 halves squared plus y minus 2 squared equals, I'm still missing my radius. And again, I've got options. What's one option? Plug in 0, 0. That's the way easier option, right? Of the two, because you can choose either one to plug in. Obviously, if you've got 0, 0, that's the better option. So I could do 0 minus 3 halves squared plus 0 minus 2 squared equals r squared. So negative 3 halves squared is 9 fourths. Negative 2 squared is 4. 4 is the same thing as 16 over 4. So this is 25 fourths. That's your radius squared, right? So in the equation, it stays squared. If it had asked for the radius, I would square root that.
But this isn't plus and minus, right?
Correct. There's no such thing as a radius that's negative. Yep. Good question. Normally, you would do plus and minus, but there's no such thing as a negative radius. Okay, so that would have been the radius if it asked for it. Your other option is to find the length of the diameter and then cut it in half, and that's your radius. Just be careful with that option because a lot of times people forget to cut it in half. That's probably like more mistakes than what we just did, but it's definitely an option. Find the distance between those two, divide it by 2, but then square it when you put it back in your equation because it's r squared.
So it technically be your whatever, like it technically be 25 over 4. Like you don't have to simplify it if it was asking for the radius.
So if we did it the way that we did and it didn't explicitly say find the radius, then you just have to get a 25 over 4. You don't have to square root it. If you go through the process of finding the distance between these two, you're going to end up with 5 over 2 as your distance. Or no, it's going to be 10. No, because you're going to have to divide it by 2, and then when you plug it in, you're going to have to square it. Okay. Does that make sense?
Yeah.
Okay. So it'll end up being 5. You'll have to divide it by 2, and then you'll have to square it. So this, you're given the reverse. I'm giving you the equation, you're giving me the information. Okay, you just have to pull it out. So this says identify the center and the radius, then graph the equation. If you look at A, it gives you x minus 2 squared plus y plus 1 squared equals 4. What's my center?
2, -1.
Good. Always the opposite sign. 2, -1. And the radius? 2, because you got to square root what's there. And then just draw it. So 2, 1, 2, -1 is there. And you're going to count right 2, because that's your radius. Down 2, that's your radius. Left 2, that's your radius. Up 2. And this is a really bad circle, but you're going to make it prettier than mine. Like that. Okay. How about B? What's your center?
0, 0.
Good. There's no H and there's no K, which means it's 0, 0. And then your radius would be? 3 halves. Square root the top, square root the bottom. So 3 halves. So I'd start at 0, 0. Right 1.5. Up 1.5. Left 1.5. Down 1.5. Connect your points. That's really struggling, but you get the point. Questions on anything we talked about today? So I know it's a lot of information. It's a lot of review information, hopefully, but it is a lot of information. Okay? Your assignment tonight is the last of the PDFs you're going to get. It's a PDF. It's on Canvas. It's R.2. Okay? If you're still struggling to get into Canvas, we need to do something about it at this point. So no longer am I going to get the excuse that it's not working. We are going to fix it. because there's a fix. Okay, we just have to figure it out based on your issues.